Hello everyone, amateur meteorologist FirstinWeather here. This is my 2023-2024 winter forecast. It is November 24th, 2023, and this is going to be a pretty long video here going into all the details and my insights into the winter forecast for this year, my thoughts, and what I think is going to be happening in terms of temperature, precipitation, and snowfall. So enjoy the show, and let's get started here. So, what are some of the factors that I'm really looking into for this winter forecast? You can ignore the preliminary label there. This is my final and only winter forecast for this year. So, of course, you have ENSO, one of the biggest drivers of the winter and the atmospheric forcings. You have the QBO, you have the PDO, the Pacific Decadal Oscillation, the NAO. Also, dynamical models. Dynamical models can be a very helpful tool in sort of understanding what's going to be happening with the atmosphere, especially over the last 5 to 10 years. They've gotten quite accurate in sort of discerning what the pattern is going to be in general for the winter, and they're definitely valuable tools that should be utilized to understand trends and sort of signals that we can pick up from the models. And also, the last bullet point is a deeper analysis of each analog year. I kind of already did that in this winter forecast, so this should also be bolded as well. So first, let's start off with ENSO. It's no quite big question, or it's no controversial statement to say that we are in an El Nino this year. The September observed ONI for the 3.4 region was 1.47 C. That is right around smack dab in the strong, weak, or just about the moderate El Nino category, and that is projected to increase and strengthen as we head towards closer to the winter months. Now, I do also want to point out that over the past few months, there's been pretty strong divergence here in the models, with the dynamical models being very aggressive, pointing to sea surface temperature anomalies approaching 2.3, 2.4, a strong consensus from those models to approach 3.4 anomalies well in excess of 2.0 or around it. While these statistical models, and also these statistical averages and official forecasts, have been a bit lower. For example, the green and blue lines here show a peak value of around 1.6, 1.7 into the winter months, and that steadily declines and decreases as we get closer to spring. So that is kind of where some uncertainty does lie. For this winter forecast specifically, I kind of didn't really focus on the raw numbers, what exactly the SST anomalies are, but rather how the atmosphere is responding to it using a variable known as velocity potential anomalies. And I'll get into that later into this forecast, but that's just a quick note there. And I also wanted to point out that the dynamical models definitely have been overestimating the strengthening of the El Nino just a touch. They do have and are known to have a bit of a warm bias when making El Nino forecasts. So that is also something to keep in mind when looking at these dynamical model outputs. But overall, I think, looking just at the Nino 3.4 region during this winter, we are going to be flirting with strong territory, if not going to be in strong. I think it's definitely possible, and I think some areas already are seeing values well in excess of 2 degrees Celsius. Not quite there yet with the 3.4 region, but we certainly will be close. However, it's also important to point out that these values will be decreasing steadily after the January timeframe. So here is just a general sort of overview of the anomalies right now. The 3.4 region is kind of in this region right here where my laser pointer is. You can see the values here a bit lower, but especially to the east, you have some very strong and positive anomalies, 2.5 even, and even higher than that just off the coast of South America. And as you might know, when those water temperature anomalies are very strongly focused on the eastern side of your typical El Nino basin region, that is often considered an eastern-based El Nino, where the strongest anomalies are, as the name implies, focused a bit further to the east. Now, you also have some stronger anomalies to the west here, and this is a bit unusual, where you see the strongest anomalies in the east, and then also on the far western side, near the date line. That's something that's not too common, and that also might be playing a role into why things this year have been just a bit different in terms of the atmospheric response to an El Nino, and again, I'll get into that in a little bit. So here is a composite of all strong or very strong El Nino. So again, above 2.0, above 1.8, whatever category you have, but just in general, strong El Ninos. And you can see it paints a picture that's really not too favorable if you're in the Mid-Atlantic or the Northeast. El Nino winters are known for their big boom or bust, with some winters having almost no snowfall, some winters having huge amounts of snowfall when you have the right storm track coincide with the shot of cold air. The most famous association with an El Nino is a very, very strong subtropical jet stream, and you see that here pretty nicely. On the left here, you have your geopotential height anomaly from the 1991 to 2020 climatological base period, and you can see you have all these below average heights here, indicating the strong presence of the subtropical jet, bringing lots of precipitation. So if I also had a precip anomaly map here, basically the entire southern third of the country would be very wet. And then you have not much high latitude blocking, some below average geopotential anomalies over Greenland, and some above average anomalies over Canada and the northwestern or central U.S. And so that paints a pretty warm picture for a large portion of the country. Keep in mind that now today, when looking at this composite on the right, areas in the average section, such as the white shadings, would be in the slightly above average areas today just because of global warming and climate change, while areas in the light blue would see average conditions, and then areas far south here, like in Florida and southern Texas, those would be in the slightly below average category here. And you can see that the composite is quite warm for a large portion of the country, basically the middle section all the way up. So the Mid-Atlantic, the Northeast, especially the upper Midwest, all have a very warm signal when looking just at strong El Ninos and their composite. And here's another look at El Ninos and kind of what the atmosphere has been doing so far. So as you might remember, we've been in La Nina now for the past 3 years. Only the third time in history we've had a triple dip La Nina, with La Nina conditions 3 years in a row for each winter. We are finally now seeing a very robust and strong atmospheric response in the opposite direction, seeing temperature anomalies go above average. And you'll see that right now, the latest observed reading, this was, I believe, from September, was 1.5 C in the 3.4 region. So again, smack dab in that moderate category. This image right here below shows the equatorial temperature anomalies as you go further down with depth. So the far east part is right next to South America. The far western part is on the other side of the Pacific. And what I want to point out here is the large amount of warmth extending down into the surface, all the way down to 200 meters. And all this warmth is going to be tapped into. It's not too impressive on the eastern side, but this warmth in the central Pacific is also quite impressive. And I think as this El Nino progresses, the fact that this warmth is a bit further to the west than right next to South America, that also has some important implications for how this El Nino will progress, whether it'll strengthen on the eastern side or progress westward in its strongest anomaly zone. And historically speaking, with most El Ninos, the warmest temperature anomalies tend to move westward as the season goes on, becoming more western based. Obviously, it's still going to be an eastern based El Nino, but the strongest forcings and temperature anomalies will be sliding further west as we go later and later into the winter. But the fact that we're already seeing those anomalies in the kind of the strongest anomalies below the surface being in the center Pacific, that also kind of lends credence to the fact that the eastern part of the El Nino region isn't going to be seeing the most strengthening over the next 2 to 3 months. Now here we can take a look at the model forecast for ENSO. This is the C3S multi-system seasonal forecast. So it takes all the major global models, the European, the UK model, the French model, the American model, the Japanese model, etc., etc. It goes on and on. And this is the sea surface temperature anomaly forecast for January 2024. And what I want you to notice here is that the strongest anomalies are focused in or just south of Alaska. So from Alaska to the California coastline, that's where the strongest anomalies are. Notice that the strongest anomalies are not focused off the coast of South America, as would be a typical eastern-based El Nino. Now, I want to make it very clear, this is in no means a central-based El Nino. People sometimes rush to label things as a central base or a Mordecai El Nino. This is just not the case here. To have a Mordecai El Nino, you would need almost cooler waters off the coast of South America, and those warm waters to be way, way further west, almost south of Russia, essentially, with those warmer waters being all the way out west. This, again, is by no means a central-based or Mordecai El Nino. But these model forecasts here, and the general consensus of all of them, to have those warmest anomalies not off the east coast of South or the coast of South America, but a bit further west into south of Canada, California, and Alaska, indicates to me that we're not really seeing a pure, very strong east-based El Nino. And again, if I haven't mentioned before, the difference in El Nino type, western-based or east-based, has a huge impact on the overall forcing from the atmosphere and what happens in a particular winter. So here is a map showing the current sea surface temperature anomalies. This is as of November 22nd, 2023. And on the bottom left, you have the Nino regions pointed out quite nicely for you. And what you'll notice again here is that you have a strong region of above average anomalies just off the coast of South America, and you also have a stronger region further west. And again, like I pointed out earlier, this is not something that you typically see. This also makes the forecast a bit muddier and adds a bit of complexity to the response that the atmosphere will see from this particular El Nino. So just wanted to note that here and show you guys what I'm seeing, and that's the fact that we have these warmer waters extending a bit further to the west, making it harder to make the argument that this is a pure eastern-based El Nino, at least in my opinion. Others disagree in the field, and they have valid arguments as well, but this is how I'm seeing things right now. Now, to remedy this, what you can do is, another great tool you can utilize is velocity potential anomalies. This is at around the 200 millibar level, and it measures the atmospheric divergence or convergence. So purple values here indicate divergence. And so if you have divergence aloft, you would need rising motion at the surface, and that typically corresponds to where the warmest temperature anomalies are in terms of the water, because where you have warmer air, warmer water, air tends to rise, and if air rises at the surface, it's going to diverge when it meets the tropopause or the jet stream, and so that's what the purple anomalies indicate. The green or yellow colors indicate convergence, because to have sinking motion at the surface, you would need convergence at the top of the atmosphere. And so it kind of gives you a good picture of how the atmosphere is responding to this El Nino or a particular El Nino. The image on the left is the August to October averaged velocity potential anomaly for 2023. And you'll notice that you have a very strong sinking anomaly on South America, North America, in India, and in the Western Pacific. And then you also have very strong rising motion kind of further west into the Pacific and also the Central Pacific. Now the image on the right here takes a look at some analogs. So 1957, 65, some strong to super strong El Nino years, even some moderates thrown in there. And you'll see that there's pretty good alignment with sinking motion over the Western Pacific, rising motion in the central part, and sinking motion again in the eastern part, right around South America and North America. However, what I want to point out here is that when looking at the velocity potential of your traditional strong El Ninos, that rising motion is focused way further east, basically on the coast of South America and just to its west. Years like 2015, 1997, and the fact that we're not seeing that this year, even with these really strong anomalies being forecast, that indicates to me that this year's El Nino is not going to be behaving like your traditional super El Nino or your super strong El Nino that we saw in 2015, because of the fact that the rising motion is focused a bit further to the west. And again, these rising motions and sinking motions have huge impacts on how the atmosphere responds and behaves to an El Nino, because in the super strong El Ninos like 1997, 2015, when that rising motion is focused further east, just off of South America, that impacts where your troughs and ridges set up in the mid-latitudes. And so if that rising motion is further west, that can impact where your ridge is. So instead of being on the east coast, your ridge is instead on the west coast. That makes it easier to have cold air in the east coast during the winter. So it's very important here to get this right, to understand how the atmosphere is responding to the El Nino and getting a clear picture of what's going on. Another variable I want to take a look at to show that this El Nino is not your typical strong to super strong El Nino is the MEI index. This is essentially a measure of the atmospheric response to the El Nino. So you have your 3.4 anomalies in that zone, but this right here measures how much the atmosphere is behaving like it actually should be based on the current ENSO state it's in. And so all these years right here, 83, 87, 92, 1998, Those are all years, in 2016, those are all years that had a strong to very strong El Nino. And you'll see the MEI index for those years was above 2.0, was above 1.5, corresponding pretty well to the actual observed 3.4 anomaly of 1.5 or 2.0. What you'll notice, though, is that 2023 is struggling to reach the actual value it's at. So right now we're at 1.5 degrees above normal at 3.4, but right now in 2023 the MEI index is around 0.4 or 0.5, and so this kind of gives more confidence to the idea that, again, we're not seeing your traditional response to the El Nino. This is not your grandfather's El Nino or your father's El Nino. We're seeing a different atmospheric response to these very strong anomalies. What are the causes? I mean, who really knows? It could be the orientation of the water temperatures being further west. It could be global warming, with warmer sea surface temperature anomalies being focused everywhere around the globe. That kind of distorts the atmospheric response and forcing associated with the traditional El Nino. And so these are all things that are important to take into account and look at here. So keeping that in mind and having that as consideration, instead of looking at just El Nino years that were above 1.5 C, a more kind of accurate or nuanced approach would be to look at all years that have the similar velocity potential. So look at years that are matching the velocity potential we're seeing in 2023, with rising motion in the central and western Pacific, sinking motion along Australia and westwards, and then sinking motion along and basically over North America and South America. What years correspond closely to that? And those years are 57, 1965, 72, 2009, 1987, 63, 68, 1951, and 2002. 2015 and 1997 velocity potentials show maximum rising motion further east, again showing that this current El Nino does not have the flavor of a typical super strong El Nino. 1991 and 1982, which were also previously analogs, are also now removed because they too are very different from the forcing response we're seeing this year from the El Nino. So now if we take a look at all those non-analogs selected above right here, and we look at what was going on in the atmosphere at that time, this shows what the PDO state was and what the QBO is doing. So this year we have a easterly QBO that is descending. Some of these years have positive QBOs rising, descending, etc. And you have some years with a negative PDO or a positive PDO and how they're trending. So now here is the analog composite when taking a look at the years with similar velocity potential anomalies oriented basically like how this year is oriented. And you'll notice that we have a very, very dramatic change. So you went from this, right? So the warmth being a lot further south, to this, where the warmth has retreated up until the far northeastern portions of the country. The cool conditions have spread further north and west, encroaching all the way down to I-64, going all the way up to California. Now keep in mind this might be a bit overdone because of global warming, so the actual below temperature anomalies might be kind of focused to Virginia and the southern portions, but again, it's a clear picture of these warm anomalies being much, much less strong here. And it indicates, again, that it would be a mistake to loop this winter with your traditional strong El Nino and just call it a day and say it's going to be a warm and snowless winter. That definitely is not the case here, and this is why. Because of the velocity potential anomalies. Now, looking at the figure on the right, this shows the precip anomaly composite from all those years. It shows a very, again, as expected, a very active subtropical jet stream, very, very wet along the I-95 corridor in the southeast. California remains wet, which is interesting, and the Pacific Northwest stays quite dry. So, pretty interesting trend here. Very, very sharp reversal from what was shown just a few slides ago. And now if we move on to this and go at the actual geopotential height anomaly composite, again, looking at the same years that match the velocity potential anomalies, you'll actually see there's a very, very interesting signal here for a negative NAO, believe it or not. The previous, again, composite showed almost no blocking over Greenland. This one shows a pretty potent negative NAO taking place during the winter, active subtropical jet stream, below average height anomalies over the east coast, indicating quite a bit of storminess and unsettled weather, and some storminess over the west coast as well. So again, not a slam dunk by any means. This would actually support some Pacific air flooding in because of the below average height anomalies over the west coast. So this by no means is a very cold signal. What it does show is a very active and stormy signal for the East Coast and for the United States in general, not necessarily a very cold one, but definitely an interesting result as well. Now we can take a look at some teleconnections and switch gears a bit, looking at the analog gears and how they respond. One of the main kind of or important teleconnections in the atmosphere is the quasi-binaural oscillation. It is a measure of the wind speeds way up in the stratosphere, and they oscillate from easterly to westerly. And some research here, courtesy of FirstinWeather, has found that when the QBO is descending during a winter, there is a correlation for cooler temperature anomalies. When the QBO is negative and trending positive, it is warmer. When the QBO is positive and trending less positive, it is also a bit cooler on the East Coast here. And you can see here the correlations on the left. Not too great, but there is definitely some sort of trend here, with the warmest trend or signal being positive and trending more positive. That is not the case this winter. We are trending more negative by going easterly. So look at figures here, A and C. Emphasizes some warmth in the northwest and some cool conditions in the south and eastern part of the country. And if we look at the figure here on the top, this actually is outdated. I need to update this. But for the QBO this year, we are currently in the easterly phase, decreasing as well. Let me actually pull that up for you guys very quickly. So if we look at the QBO index for this year, you'll notice that we're positive, but we're trending negative. And so I think by November and December, we will be firmly in the negative category here. And so that's important to keep in mind. Let me actually just update this image before we move on any further. So as you can see, we are trending more negative this winter, and I think that also, again, is another cool signal for some cooler weather off the East Coast and some warmer conditions off the West Coast. What about the NAO? Typically, I don't really forecast the NAO outright. I usually look at the analog to see what the NAO response might be to the atmosphere. I find that to be a more practical tool, but it also doesn't hurt to look at model forecasts like the European North Atlantic Oscillation Anomaly Index forecast. This right here is the forecast for the next few months. You can see for December, it's predicting a pretty strong positive NAO. And keep in mind, these models really aren't too accurate. For example, the recent ensembles have shown a negative NAO actually taking place over the region for December. But you can look at the overall trend, and it shows a generally decreasing NAO as you get further into the winter, with the NAO essentially bottoming out in February. That's an interesting trend. It kind of suggests that some of the dynamical models are leaning towards a backloaded winter with a warmer December and sort of cooler conditions and stormier conditions as you head further into the winter months such as January and February. Now this study or paper right here has a figure which shows how the NAO correlates with the Nino 3.4 region. So if you look at the x-axis here, as your Nino region increases, there is some sort of relation actually between a positive Nino 3.4 anomalies and a bit of a negative NAO. How strong this is, not too great. I think it's a good way to see the general trend, right? So when you have a positive El Nino phase, you can sometimes be more favored to see some more negative NAO winters as well. Now this right here looks at the PDO, or the Pacific Decadal Oscillation. Now it's no question here that we have been seeing a very negative QBO, and I think that's mostly been caused by just how warm it is off the coast of Japan. These extremely warm sea surface temperatures off the coast of Japan, the relative cool waters off the East Coast, all indicate a negative PDO and the atmospheric response towards it. You can see on the figure on the left here, the QBO has been very negative, values around negative 2.5, even negative 3 in September. We are decreasing a bit as we head further into the winter because maybe of that El Nino response, but I think even by the time we reach December or January, the PDO response will still be quite negative, and that's going to have a pretty important play into our winter this year. particularly because a lot of El Nino winters tend to see a positive PDO, where you have warmer waters off the west coast and cooler waters off the coast of Japan. So that also complicates things a bit as to how we look at this winter forecast. And we can take a look here at the multi-model seasonal forecast. They also show for the January 2024 period warmer waters still being concentrated off the coast of Japan, which makes me confident in believing that the PDO will remain negative for this winter. It might not be as negative as it was over the past few months, but it still will be, particularly or rather strongly negative, around the -1 to -2 range for most of the winter. So now, let's look at the analog years, and let's look at what was happening in terms of the PDO and the QBO, and group them into different groups, right? So, again, these are all analog years that have been selected because they have similar velocity potentials to the moderate El Nino, and were at least a moderate El Nino during the winter, or at some point during the year. So, we can eliminate 1965 and 66, and the winter of 1972 and 73, because both had a positive PDO, and they also had a negative QBO that was rising or steady. So that is against what we're looking at this winter. If we then switch gears and look at the overall pattern in general, and then look at the remaining winters, so 57, 2009, 87, 63, 68, 51, and 2002, we can group those winters into these groups right here. So you have group number 1, which is warm east, cold west. That's 51, 52, and 72, 73. You have group number 2, which is basically the entire country being cool. Not really any extreme anomalies on either side, just generally below average or slightly above average. Then group number 3 is a very cold east and a very warm west. So a very polarized winter. That's 2009, 2010, the winter of 63, 57, and 2002. So how do we find analog years? Well, what we do is we look at the factors that we've outlined here. So it has to be a moderate to strong El Nino, an easterly plus descending QBO, a negative PDO, and we need 2 out of 3 conditions to be met for it to be considered an analog year. And so with that in mind, we now have 6 years to look at. Again, 57, 09, 87, 63, 68, 51, and 02. And those are the primary analog years for this winter. What was the result? So if we look at the December through February geopotential height anomaly composite, again, a very strong negative NAO signal popping up here, indicative of, some significant high latitude blocking, particularly during the later winter months, it looks like. Very active subtropical jet stream, very stormy off the east coast, as evidenced by the below average geopotential height anomalies, and again, below average height anomalies off the west coast, indicating that the west coast will also be quite stormy and unsettled, and the subtropical jet will be quite active. This kind of reduces the chance of seeing extreme cold, I think, when you have these below average height anomalies off the west coast. That does kind of reduce the cross-polar flow, and it can help keep things a bit milder with some Pacific flow across the country. Now, if we look at the composite in general, looking at precip and temperatures, you can see definitely a colder picture here, especially for the southeast, Florida, the deep south, but with seeing below average conditions. The only places that see above average anomalies are northeastern Maine and also the extreme northern portions of the Midwest. And for precip, again, the southeast is very wet California, and a very dry Pacific Northwest, including Seattle and Washington State, and some dry conditions here in the Ohio Valley. So, another thing we can look at is a similarity tool to kind of see what years are most similar to how this year is progressing. So the idea here is to look at the geopotential height anomalies over 2023 and then see what years in the past are most similar. And so ideally what that does is you can look at how the atmosphere is responding. And so you can say, well, hey, based on how the atmosphere is responding in 2023, what years in the past 70 years have the most similar atmospheric response? And so this is a tool I made using Aerified reanalysis data of 500 millibar geopotential height anomalies. And interestingly enough, using the similarity tool, the analog years of 68, 09, and 51 popped up. Now there's just one issue. 68 in 2009 are very cold winters on the East Coast, but 1951 is one of the warmest winters in East Coast history. How can both of those years be top analogs using this tool for the upcoming winter? How does that work? And so again, this right here just shows kind of what the model did. So it looks at geopotential height anomalies for various months, and then it uses the mean squared error for each lat long grid value to see which areas are the most similar, and it then makes a similarity score, and it chooses the years with the lowest error values. And so again, these are the years that were the top 10 most similar years to this year. And months that were further back in time are weighted less. So January had a 1% weight. July, August, September, October had higher weights, around 15 to 20%. And this was the most similar. These are the two most similar years. Again, on the left, 1951-52. On the right, 09-010. And what this indicates here is that you have a lot of variability in some of the analogs. Again, 1951-52 was removed from the analog composite before because it wasn't quite matching up. It did have a negative QBO and a negative PDO, but it was removed for reasons I'll explain here. But I do want to state clearly, though, this is a major risk to the winter forecast, the fact that both of these years are showing up in the analogs and also in the similarity tool. This does make me a bit wary of something that could go wrong here by seeing, 51, 52 taking place. But I do think that is unlikely, and I'm going to explain here why in a second. So you can see on the left, December to February, 1951-52, very, very warm on the East Coast and the Deep South, and very cold on the Western Coast. A record cold winter for the West Coast, and a record warm winter for the East Coast. While in comparison, 09-010 was a record cold winter for the Deep South, the Midwest, and the East Coast, and very warm for the Northeast and also the Western U.S. So just a tale of two different stories here. A very cold winter on the right, a very warm winter and snowless winter on the left here for the East Coast. However, can 1951 and 1952 be ruled out based on the fact that it is in fact an outlier? And what you'll notice here is that the image on the left shows the geopotential height anomaly composite for 1951. You'll notice that we have, very below average height anomalies over Canada, over the Arctic, and the Western U.S. The figure on the right here is the multi-system model forecast for December. And while both of them do have a negative NAO signal popping up here, the image on the right has pronounced and strong above or positive geopotential height anomalies over Canada, which December 1951 does not. And so it kind of does help to indicate that the atmospheric response in 1951 is a bit different from what we're seeing this year. It's also important to notice that in December 2023, the subtropical jet also does appear to be quite a bit stronger, with below average or average height anomalies extending off the East Coast and also the southwestern U.S., which 1951 does not have. So that's something to keep in mind here. Again, I don't think it completely rules it out. I think if you head into December and you see a record warm December for the East Coast, and the same thing happens in the first half of January, then you can kind of be confident here that this could be a repeat of 1951-52. But overall, I think it doesn't look as likely. You can look at December to February 1952, looking at the entire winter, and you'll notice that we have very, very strong below average height anomalies over the West Coast. This kind of indicates there was some sort of major polar vortex disruption and Arctic outbreak on the western part of the country, which messed up the temperature anomalies. And on the eastern part of the figure, this is the geopotential height anomaly forecast for the winter in general, using, again, the multi-system seasonal forecast. And it's quite different here. You have, very active subtropical jet, bringing a below average height anomalies to the southeast and the southwest, and above average height anomalies to the north, which is not really how the winter of 51-52 behaved. And I think because of how all the models are in this agreement here, that we're going to have this sort of picture on the right, it does give me some confidence that 51-52 is relatively unlikely. What's the odds of it happening this winter? I would put it around 15%, 10 to 15%. I think it's definitely not impossible. It's definitely a possible solution, but the way it looks right now, I don't think it's the most likely one by any stretch of the imagination. And you can also look at this figure here. looking at the analogs that we had before, it lines up really nicely with how the model forecast, so the dynamical model forecasts are thinking this winter will go. And this again, it gives me some more confidence in that this 1951-52 is in fact an outlier rather than a bellwether for how this winter might actually behave. All right, I want to switch gears here a little bit and shout out another meteorologist on the Twitter, platform, Eric Webb. He is a meteorologist from NC State, and he's an expert on ENSO forecasting. And I think he actually had his master's program in ENSO recording, and it's basically the study of El Nino. So this guy's an expert in the field, and he recently posted a composite using different variables. So you can see here that the figure on the left is a weighted December through March 500 millibar height anomaly for El Niños with a positive IOD, which we have this year, a negative PDO, a negative NAO in December, which is what some of the models are indicating for this month, and a positive AMO, which again we have for this year, and he went back all the way to 1855. And here he says on the right that weights have been applied to account for El Nino strength, so a 2 times weight for just strong or super El Nino, a negative PDO, positive IOD, positive AMO, and appearance of a negative North Atlantic oscillation in December. And again, this is from meteorologist Eric Webb. And from the figure on the left here, you can see that it corresponds very nicely to what the analogs show. Again, a very active subtropical jet, below average height anomalies in the southeast and mid-Atlantic, and above average height anomalies in the northwest, with some high latitude blocking over Greenland and some blocking also as well over most of Canada. And taking a closer look here, again, these are all figures from Eric Webb. The figure on the left is the December through March temperature anomalies, and so again, lines up very nicely with the analogs I have above. If we go back here, cooler southeast, warmer north and northwest. The composite from Eric Webb shows the same thing, cooler southeast, warmer northwest and northeast. The figure on the right here shows the height anomaly probabilities, and you can see areas in the southeast have a 10 or 20% chance of seeing height anomalies being above average, with indicating generally cooler conditions in this region of the country. So it's encouraging to see this agreement is using this kind of different analog tool from Eric Webb, which goes way, way back in history to 1855, and looking at the different variables that occurred during that. And again, it's important to note here that Eric Webb used a sliding 30-year climatology to account for climate change and changing seasonal norms. Now this right here is for December specifically, and here you can see there's a bit of a warmer look. You have warmer conditions in the northeast and in the Pacific Northwest, cooler conditions in the southeast and extreme southern U.S. January is when things really kind of pick up. I think this also lends confidence to the fact that this winter will be a bit more backloaded with a warmer December and a cooler January, February, and March. A very warm west and, again, cooler conditions in the southeast, and this corresponds nicely to the geopotential height anomalies. For the month of February, same thing, cooler conditions in the southeast. The cooler regions do shift a bit further to the east, and it does warm up quite a bit in the western U.S. And finally for March, same story. Cooler conditions in the south and southeast. Those cool conditions might expand a bit further to the north, and it remains warmer out west. So now we can take a look at the month-by-month basis of each analog. This is looking at the analogs I've selected above and the geopotential height anomalies for December. So these are the years. And I want to point out here that you have, once again, a very strong negative NAO signal. Very stormy conditions on the East Coast. How much this verifies, I am not sure. I think because you have all these below average height anomalies extending all the way off the West Coast, I think this is not a very cold look. I think it is, though, however, a stormy look, especially for the Northeast and Mid-Atlantic. I don't think there's going to be snowmageddon for December, especially for the Mid-Atlantic or Southeast, but I do think it might be relatively unsettled and not as warm as people might expect. And this is the composite for December. So again, anything in light green or blue, make that white, and anything in white, make it yellow because of changing climate. So again, pretty warm in the Northeast and the Midwest, and cool in the Southeast and southern tier of the country. And for precipitation, again, same story here. Very wet Southeast, wet California, and relatively drier Pacific Northwest. For January, I think this is when things really start to heat up. you can start to see a bit of a more cross-polar flow regime set up with below average height anomalies off the east coast. Again, big and negative NAO signal, which is pretty surprising to see. This is a very strong signal right here. And I think January is when things will really start to heat up for the east coast, particularly the mid-Atlantic as well. This is when you can really start to see some impressive storms start to take shape. And this is temperature anomalies and precip. Again, much warmer northeast and western part of the country. The southeast stays downright cold, it looks like, from all the rain and snow and basically active and unsettled conditions. Precip, not too strong of a signal, but generally wetter, western part of the country. Maybe even some dryness encroaching in the Ohio Valley going down southward. But I think this might be a bit overdone. I think, in general, the East Coast and especially Florida will stay relatively wet. And for February, this is the big blockbuster month. Historically looking at climatology, your greatest snowfall anomalies in strong or moderate El Nino winters tend to happen right around the end of January and the beginning of February. You can see here another pretty big, impressive negative NAO signal and below average two potential height anomalies off the East Coast. I think the end of January and the beginning or first week or week and a half in February could be your big time potential zone for seeing significant snowstorms off the East Coast, in the Northeast, and the Mid-Atlantic. I think we won't really see any big snowstorms in the East Coast, particularly south of I-64 along I-95 during December, but I think, again, January and February are your months to keep track of and to watch closely. And this is February right here. This is pretty interesting. The bottom basically falls out with a very cold February in basically areas along and east of the Mississippi. You can see that snowstorm signal showing up here with above average precip anomalies along I-95, the southeast, and a dry Pacific Northwest and a dry Ohio Valley here. Very interesting signal. And this again shows the fact that this winter is likely to be more backloaded with stronger cold anomalies and more stormy and potentially snowy weather as you go further into the winter. And finally, for fun, here is March. This is also pretty interesting. You see a very strong area of below average height anomalies in the central U.S. Keep in mind this is a bit overdone because this uses 1991 to 2020 climatologies, and these years are primarily about 50 to 60 years back. So because of global warming, this is a bit overdone. But again, you can see the main picture here is very unsettled and stormy in the central U.S. and the East Coast. So it would not surprise me if we also see a late winter as well, and winter extending well into March with that negative NAO signal still being a bit present here. And this is the temp anomalies for March and the precip anomalies for March. So you can see that cold actually shifts a bit further to the west, more in Texas, New Mexico, Arizona, Colorado, and Kansas, with some warmer conditions now encroaching in the northeast. It also shows some drier conditions in the Ohio Valley, the interior northeast, California actually, with the only real wet places being the northwest and Florida. So now we can take a look at the models. What do the models say is going to happen this winter? This again here is the multi-system forecast for December, January, and February, the ensemble mean of those 3 months. And it's actually very similar to what the analogs show. High latitude blocking or some blocking in Canada and below average height anomalies on the southern third of the country. This again shows a very active subtropical jet, conditions being stormy, unsettled, not necessarily very cold, but unsettled and stormy. Now we can also take a look at the European and UK Met plus Meteor France C3S snowfall anomaly forecast. This is from Ben Null Weather. He's also on Twitter. And these models also have been pretty accurate. And you'll notice that it shows an expansive region of below average anomalies, basically over the entire US. And this surprised me a bit. I'll be honest, I don't necessarily agree with what the models here are showing. I think because of the analogs, because of the composite generously generated by Eric Webb, I do think this above average zone of snowfall is going to be further south, while Canada will see below average snowfall here. And I know it might not be wise to go against what the models are showing, and particularly when this tool has been known to be relatively accurate. I just think that based on the factors we're seeing this winter, the fact that the atmosphere is not responding traditionally to a strong El Nino, I think this winter will be quite different, and we won't really see these below average anomalies, at least on the East Coast. Now here's some wild cards we have to take into account. Again, the stratosphere. You can have polar vortex warmings or significant stratospheric warming events where winds become easterly in the stratosphere, and that can often cause big impacts downstream at the surface, especially in the mid latitudes. One potential wild card is if we see a sudden stratospheric warming event. And like in 51-52, we see all that cold air go in the western part of the country, making a ridge be amplified off the east coast, bringing in record warm conditions. That's a possibility. That's why I said it's a 10 to 15% chance. If you look at El Nino winters, about 6 in 10 have a SSW event. Looking at Siberian snowfall cover and some other things, and some analysis by Judah Cohen, a meteorologist and researcher with AER Weather Risk, it looks like over the next few months, the QBO or the stratospheric polar vortex will not see a significant weakening, at least the way it looks right now. It's possible that we see a weakening or a stretching, but an SSW right now is looking unlikely, at least the way it looks right now. This right here is the ensemble forecast for the polar vortex, and actually you can see that we're going to approach record strength over the next couple of days, and then generally the models do show some weakening, but again, nothing too significant. I think the polar vortex might not be a big player this winter because of the fact that the subtropical jet stream will be the main player here, making things very active, very unsettled. But we might see some interesting activity in the end of January and February. We might see a weaker polar vortex during that time frame. Another wild card here is the stratosphere. Again, because of the Hunga-Tunga volcanic eruption that we had about a year ago, we have record water vapor anomalies in the stratosphere, and this has been shown to cause warming in the upper levels and also warming at the surface. So this is a wild card here. This could impact the winter in ways that are unforeseen. The way it looks right now, I don't think it should have too much of an impact, but again, it's something that also is a wild card that should be taken into account. So, without further ado, here is my 2024 winter forecast in terms of temperatures. And you'll see here that I have a wide swath of the country, the Pacific Northwest, the Western U.S., the Upper Midwest, and the Northeast, in above average temperatures, about 2 degrees to plus above average. So, nothing crazy, but I do think these areas will see temperatures being above average. In this region in between, I think temperatures will be slightly above average, 1 to 3 degrees above average. In this region right here, I think you have equal chances. Conditions should be basically around average. And then finally, I think in the southeast, Florida, Georgia, southern Texas, Louisiana, I think temperatures will be about -1 to -3 degrees below average. So pretty similar to what the analogs show, what the composite shows, and what the models show. Again, I just moved the cold down a little bit. I've noticed historically that now, especially in the last 5 to 10 years, when the cold is a bit underdone, especially with climate change. It's very hard to get a large region with below average temp anomalies. But I think the area to do it this winter will be the southeast. In terms of precipitation, this forecast goes right with the analogs. I think it's going to be a very wet southeast. I think Florida, the deep south, will see well above average precipitation. I think that drought in the southeast is going to be eradicated pretty quickly. I think those wetter than normal conditions will extend up into the northeast, along I-95, the mid-Atlantic, and also down into Texas. And I think California will continue the trend of seeing above average precip as in last winter, which is good news for the snow lovers down there and the water authorities there, because there has been drought for the past 20 years, and so it looks like this winter will also be quite wetter than normal for California. And finally, I think below average precip is the best bet in the Pacific Northwest and also the Ohio Valley and interior portions of the Northeast, like the Great Lakes region. So I think the Great Lakes region might be seeing an underwhelming snowfall season this year, at least the way it looks right now. And finally, this right here is a snowfall anomaly map based on ERA 5 reanalysis. I looked at each analog year, and I looked at what the snowfall anomaly was for these winters combined, or for those winters combined. And you'll see a very strong signal here. If you're a snow lover on the East Coast, this might make you very, very happy. It shows a pretty substantial and significant above average snow signal for areas along and west of I-95. We're talking the Northeast, New England, New York, Pennsylvania, New Jersey, extending down into Virginia and North Carolina into the Tennessee Valley. And there's another region of above average snowfall in Texas, Amarillo, New Mexico, Flagstaff, Arizona. And so I think this is a pretty strong signal here that essentially I-95, the East Coast, extending into the western portion of the country in Texas, New Mexico, these areas should be the most above average in terms of snowfall. Now, overall, I think this winter won't be, likely won't be a blockbuster like 2009, 2010. That is, again, is an extreme anomaly of a winter. Everything went right, multiple storms all in the same location. But what I do think is going to happen is, this winter, I-95, the eastern coast, down into the Tennessee Valley, west into Texas and New Mexico, Arizona. These areas should be heavily favored to see above average snowfall, while areas in the upper Midwest and the Pacific Northwest should see a relatively below average winter in terms of snowfall. So I think if you're an East Coast snow lover, this definitely is a winter to get a bit excited about. Definitely there is some potential to see some significant snowfall, at least in comparison to some previous years. So then this right here is my snowfall forecast. You can see again I have the above average snowfall zone basically in the interior Northeast, down into the Mid-Atlantic, slightly above average snowfall essentially everywhere in the Southeast, the Deep South, Texas, another pocket right here of above average snowfall in Texas and central and northeastern New Mexico. And then my main losers this year for the winter forecast are going to be the upper Midwest, particularly the western Great Lakes region. I think this area is going to kind of have a lackluster snowfall season. And then also just broadly the Pacific Northwest, Washington State, Idaho, Wyoming, Utah, and northeastern Nevada. So that concludes my winter forecast for 2023-2024. Thank you so much for watching. If you have any questions, please feel free to leave them in the comment section below. And thank you again for watching, and I hope you have a great winter.